All right, welcome back and to this, our final lecture in our relational terminology and theory section. In this lecture, we are going to tackle ER diagrams, entity relationship diagrams. This is how we are going to visually document our schema designs. And in addition, these technologies allow us to automatically create our schema creation scripts as well. So that is another handy part of using these tools. All right, here's my take on ER diagramming software. When you go to buy an operating system you call Microsoft, you want to play with the big RDBMS on the block you call Oracle. Well, with respect to ER diagramming software, that entity is Computer Associates in their technologies called Irwin, ER for Windows. Very nice tool, forward and reverse engineering to just about every RDBMS out there, whether it's Oracle, SQL Server, DB2, it plays with all of them. Very nice tool. I used it for many, many years. What's the bad news? Irwin's expensive. Last time I checked, it's nearly $1,000. As such, for this course, we are going to use MySQL Workbench instead for our ER diagramming tool. That allows us then to all work with one that's free. So if you haven't yet, please go ahead and download that guy and start playing with it, because that's what we're going to do in this particular lecture. What's the bad news with respect to MySQL Workbench? We will not be able to forward engineer our schema scripts. As such, I'm going to have to write those by hand. Not a problem, because I wanted to do that anyway, show you all the different variants that we can put into our data definition language. So no problem, we'll get there. All right, given that caveat, let's take a look at an entity relationship diagram and how these things work. All right, why are ER diagrams magical? They're magical because they are in your face easy. And unlike our 3NF documentation we had previously, you can actually show these things to non-technical people and talk them through them. And within a few minutes, they're understanding and knowing what they're looking at, because they're just that easy. All right, let's take a look at this one for our example schema and talk our way through what we're looking at here. All right, as you might guess, tables are shown here as rectangles with the name of the table across the top. Easy enough. Attributes are listed down the rectangle along with data type and FK references. Now note here on data types, all the RDBMSs support, the common core data types, but each also adds their own flavors. For example, my SQL here has this automatic increment data type. Oracle does not have that. Similarly, Oracle has a bunch of blob data types, binary large objects, that MySQL may not support the same way. All right, back to our diagram. Relationships are shown with these lines, and the degree of the relationship is indicated by the symbols at each end of that line. Let me be more specific. Check this out. This is a one-to-one relationship. You can identify that with the little cross lines at the end of each of the relationship line. Note, product is a one-to-one with line item. One-to-manys look like this. They have our little crow's foot at one end and the two little cross lines at the other. Customer is a one-to-many with orders. Zero one-to-manys look like this. Looks like a one-to-many, except it has this little circle or zero on the end with the two cross lines. Got it? Employee is a zero or one-to-many with itself, because the top boss doesn't necessarily have a manager. Right? That could be a zero relationship. All right, the type of lines can be either solid or dashed. Solid lines are used to indicate the existence of a child record, which is dependent upon the existence of the parent. What does that mean? It means we can't have a shipment line item record without a corresponding shipment. That child record is dependent upon the existence of the parent record. Dashed lines indicate that the child can exist without the parent. It's a base table. Products can exist whether or not they've been ordered. Finally, to see the PK or any other details of a table, just double-click that table and check the information out down here at the bottom. Same thing, you can double-click any relationship and see the details on it. Cool beans. All right, once you've got your ER diagram drawn and you've putzed with it a little bit, because invariably as you're documenting your 3NF tables, you change things around a little bit. Voice of experience starts coming through and you see things you had missed possibly, or you have some refinements on your design. All that's cool, but before you start running your scripts, you want to run one verification against your written docs and your visual docs. So let's do that now. Next step is, at least for me, once I've drawn my ER diagram, is to verify it against the written docs. So let's do that. All right, we're going to start with the customer table. Looks like I've shortened the attribute names a little. That makes sense, but otherwise everything corresponds perfectly. Cool enough. Customer addresses, yeah, looks pretty good. We have our FKs back to the state, province, country, and address type base tables, so that's good. Perfect. Orders also look good, as do our line items. Looks like I put in a field for extended price. I knew from experience that we'd need that going down the line, so I put that in there. Doesn't show here, but the standard is to calculate that guy once we get further down the line. Probably put him in a trigger. Again, here with shipments, it looks like I added a new field in my ER diagram, which I didn't have in my 3NF tables. Let's check that out. Okay, an enumeration field which takes one of two values, partial or full. Okay, you guys are code jocks, so you know what an enumeration is. That's easy stuff. Seems like a really good idea. We'll go with that. Looks like we've changed shipment line items to losing the customer ID field. Remember when we were normalizing, I said that this is common practice when we start getting too many segments in a compound primary key? No problem. It's in shipments and we can always join it back in later from there. Looks like I also moved around some of the attributes. Not a problem as long as we stay fully normalized. Use that business experience you've acquired and put it to good use. Rest all looks very straightforward. Let's just call that a wrap. All right, now comes the cool part. Once you've created your visual ER diagram and you've validated, you can now use the forward engineering components of these software tools to write the scripts to actually create your schemas. I highly recommend doing this because they're going to never mess up is the short answer. They're not going to put in typos and stuff like that. This will not be a direct correlate to what the DDL, I'll tell you what DDL is here in a short while. It's data definition language. It's how we define schema objects within a schema. We are going to use Workbench here, which is going to write a MySQL script, which won't run on Oracle. But it'll give us a good idea how this works. So let's go through the process just so you understand how it works. All right, here's our ER diagram in MySQL Workbench. To write a schema creation script, that's harder to say than you would have guessed. To write a schema creation script, all I need to do is come up here to the database menu and choose that option. Sort of like trying to say toy boat, toy boat, toy boat. Follow a few wizard prompts asking you some of the specifics about how you want things written. One of the standard prompts is, do you want everything deleted before you come back in, or do you want to use alter statements? And again, when we get to looking at our DDL scripts, you'll know what I'm talking about there. And ta-da, out pours your script. What's the bad news? As I mentioned just a moment ago, this is not Oracle syntax. that's okay. I'm going to handwrite ours anyway so you can see all the variations. Regardless, if you were working on MySQL, you'd be done at this point. Need to update your design, simply modify the visual diagram, create a new script. Reverse engineering a schema is just as easy. Connect to the schema, follow the wizards, and ta-da, you got a new painted ER diagram. Typically got to move things around a little bit so it's visually more appealing, but you know, that's easy stuff. These are great tools. Hey, come on, that's pretty cool, right? We are able to visually document our schema design. It's particularly powerful, as I mentioned, because you can now sit in front of the data owner and talk your way through these things with them and get that final validation. You know, having written documentation of an 8-table schemas, you know, that's fine. When you get a real enterprise database, and there I said it, schema, you get 100, 200, maybe even 1,000 different tables. All of a sudden, keeping these things in a WordPad document is just not a good idea. Nobody can keep that straight. As such, we use tools like Irwin to visually document them and also produce our scripts for them. If you're in a software development company, these things are almost a requirement because in all likelihood, you are going to be releasing your software product across multiple RDBMS platforms. You don't want to be keeping 5 different sets of scripts to create these schemas across each of those RDBMS platforms. You know, one for DB2, one for Oracle, one for SQL Server. That'd be a nightmare. What you do is you keep all of them in one visual ER diagram, and then when you go to forward engineering them, you just tell the tool what RDBMS you're scripting to, and sure enough, it writes the proper script. Very powerful stuff. I highly recommend it, particularly if you're going to be doing this as a professional. If you're simply learning SQL to be a better programmer, then all you really need to do with respect to ER diagrams is know how to read them. You're not going to be designing the database. If that's cool, then just put them on your wall and make yourself feel good about knowing the database design. Cool. So what did we learn about ER diagramming? First and foremost, it is a fantastic tool for documenting your design and similarly for verifying it back with non-technical users, because people can learn to read these things in a very short amount of time. It's unlike the 3NF written docs, which, you know, I suggest you do not bring those back to non-technical people because they'll fry their brain. You could go back to non-technical people with an ER diagram all day long, and they understand what they're seeing in a very short amount of time. Next, forward engineering capabilities of these tools is invaluable, particularly if you're in a software development environment across multiple RDBMS platforms. Invaluable. Singles documentation, forward engineering to multiple script environments. Very cool. Finally, the reverse engineering capabilities of these are fantastic as well, particularly if you're in the consulting business. Somebody's going to come to you and say, here's my current schema. Can you take a look at it? I need such to such optimized, or I need to work on this performance of this, or I need to upgrade to this particular new set of features. You're looking at an ER diagram in half an hour. So very nice indeed. All right, that concludes our discussion of relational theory and terminology. In the next section, we're going to run a script to actually create our schema. We'll then spend that first lecture reviewing that script and better understanding DDL, that is Data Definition Language. Part of SQL, an important part, and we're going to learn it in the next lecture. See you there. Remember, go out there, have some fun, learn something every day.